Hello dear, my name is Miss Asma Jamal. Miss Asma Jamal, I will be with you during optics lesson. So obviously this course is about the optics. What is optics? We have the big name, the science. In science, we have three main branches. The branch that study the living thing is the biology, and the branch that study the composition of the matter and the reaction of the matter is the chemistry. The third one, which study the behavior and nature of the matter, is the physics. And of course, any one of those divided later into different branches again, including the physics. Physics, which the study of the matter's nature, have also different branches. For example, the branch that study the sound and vibration, the one that study the heat, thermodynamics, the movement, mechanical, and we have one that study the light. It study the light, behavior of the light, and nature of the light, or we call it the optics. So, the main body of optics deals with the light and its behavior. As such, optics is a branch of physics. So, when we study the light inside the optics, we will study the properties of light, the interaction between the light and different matter, how can we use the optics to serve the instrument and the science, and what types of optics we have. To talk about optics and understand the idea of it, you need to know what is light. The journey to understand the light starts even before the Christ, with the Greek. It started with Pythagoras when he assumed that the light will come from the eye as visual rays emanating from the eye and striking the object, and that's how can you see, as he said. By that time, Greeks assumed the light is rays, which means it's a straight lines. Aristotle also claimed the light is just a white light. Colors are made of mixture between lightness and darkness. They also explained a little bit the idea of refraction and different interaction between the light and matter. Then came Ibn al-Haytham, the father of optics, the Muslim scientist. Then came Ibn al-Haytham, the father of optics, who left a major historic work including the Book of Optics. That book later translated into Latin and was the basic in the optic science. Ibn al-Haytham corrected the idea of Pythagoras and said the light reflects from the object into the eye and not the opposite as said Pythagoras. So for now, Ibn al-Haytham clarified how can we see. the light will reflect from object into the eye, not the opposite. Ibn al-Haytham also started the idea of camera. He built a dark room and put a small pinhole in the wall of that room. He noted that the image outside the room will reflect from the pinhole inside the dark room, but in opposite shape or inverse shape. And that was the idea of the camera. By this time, still the light is rays. Then came Newton and said light is comprised of colored particles. So the idea of particles, which means small subject, started. And he also clarified that the light composed of color. Light contains colors and not just white color. Before Newton, they invent the telescope, and then Galileo quickly improved upon the design of refracting telescope, and he used it to see the moon of Jupiter. Then came the scientist Snell, who put the famous Snell's law, which is about the light refraction. Huygens came to claim that light in fact not particles but waves. So that's the third theory. The first one, light is rays. The second, particles. And then came Huygens to say no, light is waves. The English scientist Young came to prove light is really waves. Then came Maxwell to give a hypothesis, says that waves of the light composed of two components. It's combination of electricity and magnetic waves to give electromagnetic waves. So the light in fact is electromagnetic waves. Then came the greatest scientist of the 20th century, Einstein, to say, in fact, light is photons, which means it's a small particle. So the idea or the theory of the particles started again. So what is light? Is it rays, particles, or waves? So for now, light has three theories. Is it rays, waves, or particles? Those who say light is rays, which means straight lines, build their assumption on the shape of the shadow. For example, you have wall and you have source of light. So the light will strike that wall and it will not jump, but it will build a shadow for that wall. So the light is straight lines. It cannot jump, otherwise there will not be any shadow. Then came the theory of waves. The scientist Young, the English scientist Young, came with an experiment. He calls it the double slit experiment. That scientist brought a source of light and he brought a screen with a hole in the middle and a second screen, but this time with double hole, not just one. After that, he brought a third screen, but without any holes. So, if the theory of the rays is right, that means the light will pass through the hole, the first one, and strike in this wall. And that's it. The light, if it's really rays, it cannot pass from this area since it's a straight line. But what happened in Young's experiment? The light passed from the hole, the first one, and also passed from the second hole, like that. Which means the light are really waves, not rays. So for now, light is not rays anymore, it's waves. What we mean by waves? Waves in physics means disturbance that travels through a medium, transporting energy from one location to another location, but without transporting matter. What that's supposed to mean? Let's say we have a source of light. That's the first location. So waves is disturbance that travels from the first location, which is the source of light, to another. That's the first location, the second, the third. This one will not touch this, and this will not touch this. So the idea of waves started when we noticed that when you are inside a room and you have a source of light in the middle, the light will spread all around the room. And then Young came by his experiment, the double slit experiment, to prove that light is really waves. After that, Maxwell came to say the waves of the light is electromagnetic. But what about the particles? The scientists noticed when you strike a metal with a light, the light will behave like particles. So a part of this light will absorb by this metal, other will discrete, and we call that discrete the photon, which means light contains quantity, or we call it quantum of light. So photon is quantum of light. And it's a very tiny pocket of energy. It's the smallest discrete amount or quantum of the electromagnetic radiation or wave. So the photon is the basic unit of all light. So light is particles or waves for now. In fact, Light is both. Sometimes it behaves as waves, sometimes it behaves like particles. Depends on the circumstances around that light. So when there is metal, the light will discrete as photons, making the light particles. And when you are inside your room, turning the light on, the light will behave like waves. What the particles of the light or the basic unit of the light? What we call those small particles of the light or the basic unit of the light, we call it the photon. So for now, optics is the study of light and its behavior. But what is light? As we said, it's either electromagnetic waves or small particles. We call them the photons. That electromagnetic also contain two parts, a visible area, the one that we can detect it by the human eye, and non-visible area, such as ultraviolet and X-ray. We're going to talk about those later. Historically, optics divided into two sub-areas. Or we call them the classic optics. The optics could be physical or geometric. What's the difference between those two? Let's say we have mirror and we have lens. When the wave of the light reflects from the mirror or refract from that lens, this behavior interaction between the light and different media, we call it the physical optics. So physical optics deals with the physical characters and behavior of the light. It's the theory part of optics. What about geometry? When we calculate the angle of the reflection or the size of the new image that's formed by refraction, that calculation and mathematic part is the geometric optics. So geometric optics deals with the image forming properties, interaction and behavior, that's the physical, the properties of the image form and the calculation of the image form, that's the geometric optics. Physical optics can be further subdivided into another areas such as wave optics or Fourier optics, for example, while geometric is very important to visual optics. Visual optics means the interaction between the light and very important and sensitive organ, which is the eye. In this course, we will not talk about visual optics. You will know about it later in further courses. Nowadays, we have a modern part of optics, the one that we can manipulate the light to produce, for example, the laser, the optic fibers. Of course, we still use the classic type of optics, but we improve it to produce modern type of optics such as laser and optic fibers. What we're going to study during this course, the optic course, you will understand the optics, the behavior of light, and how can we apply the optics in our daily life. Most importantly, understanding the media such as lenses, which we're going to use it later in the visual optics. In this course, you're going to have lectures and you will have labs also. So the topics of this course will talk about optics, physical optics, which is polarization, interaction between the light and different media and matters, and then the geometric optics, which means calculating the image forming properties formed by lenses, for example, pinholes, and mirrors. And those points are really important because later we're going to use them with the visual optics, but not, of course, in this course. And how can we apply the optics to use them in instruments such as in microscope, telescope, and even measuring the light and electromagnetic waves in radiometry and photometry. Those are the references that you need to read, but mostly the exam will be only in what we talked about it during the lectures. The course assessment will be out of 100, of course. 15 marks for the lab, and you're going to have presentation later. You will discuss what we have during these lectures. You will have mid-course exam, 20 out of 100, and the final exam will be 60 of 100.